Hello students, a very good evening to all of you. Today this is the third session on metal casting, and here I am live with you. So yes, students, I have an announcement for all of you that at Unacademy are launching this new batch for all the mechanical engineering students who are going to actually appear for GATE 2021 exam. So here in this course, which is actually a rank booster course for GATE 2021, this is batch B, a new batch. Mr. J.S. Gill, myself Rajeev Singh, Aditya Gupta, Ashish Bhutan, Deep Sangeet Pati, Varun Singh and Sagar Sharma will be covering all the different batches and the subjects that has to be taught in the batches. So if you are planning to take subscription, you can use this referral code RK007. This is the referral code for discount. Dear students, now let's come to the casting part. Yesterday मैंने आप लोगों को डिस्कस करके बताया था अबाउट द राइजर एंड लेट मी हैव जस्ट ए स्मॉल रिकैप ऑफ दैट कि द सॉलिडिफिकेशन टाइम ऑफ राइजर should be greater than solidification time of the casting. Yes, for that risers are designed for their minimum surface area, for their minimum surface area. Now we have different methods of riser design. So what are these methods of riser design? The first method that I am going to discuss with all of you is what we name as modulus method. So as per this method, it is said that the modulus of riser must be 1.2 times than that of the modulus of casting, which means modulus of riser should be 1.2 times modulus of casting. Now you will be thinking, sir, what is modulus? Modulus is actually the ratio between volume and the surface area. Now, sorry, whose volume? If you are calculating the riser modulus, then this will be the volume to area ratio of riser. That should be equal to 1.2 times the volume to surface area ratio of casting, VC upon AC. Yes, dear students, understood? So this is what we call as modulus method of riser design. Then my dear students, we have another method of riser design, that is what we call as Keynes method of riser design. You know what we do? As per this method, at first we find a term something called as volumetric ratio, and a term called as freezing ratio. Here the x-axis represents the freezing ratio, y-axis represents the volumetric ratio. X is your freezing ratio, which is actually given by modulus of riser upon modulus of casting. That is V upon A, volume upon surface area ratio of riser, to that of volume to area ratio of casting. This can also be written as A upon V ratio of casting divided by A upon V ratio of riser. The way you call V upon A ratio as the modulus of the respective cavity, whether riser और casting, जिस तरीके से आप वॉल्यूम बाई सरफेस एरिया को मॉडुलस बोलते हो, उसी तरीके से सरफेस एरिया टू वॉल्यूम रेशियो जो है, दैट इज कॉल्ड एज कूलिंग कैरेक्टरिस्टिक. रिमेंबर दिस टर्म. This is what we call as cooling characteristic. Now, for different process parameters, you will have this Kane curve available in your foundry lab. Okay. Now, for a given casting and riser pair, एक गिवन कास्टिंग राइजर पेयर के लिए जब आप ये फ्रीजिंग रेशियो कैलकुलेट करोगे एंड देन y विच इज द वॉल्यूमेट्रिक रेशियो, ये जब कैलकुलेट करोगे दैट इज इक्वल टू वॉल्यूम ऑफ राइजर टू वॉल्यूम ऑफ कास्टिंग. सो डियर स्टूडेंट्स, for a given pair of riser and casting, you will have this x comma y point. If that x comma y point, अगर वो x comma y point इस केन कर्व के ऊपर है, x comma y point मान लो यहां आता है, that means if you are using that riser, then the casting that you will be doing will be sound. Sound means that will be defect free. There will be no shrinkage type of problem there. That riser will be sufficient to compensate for the first two stage of shrinkage. But in case for the given pair, अगर आपको ये V by A ratio, अगर आपको ये V by A ratio मीन्स ये x, y पॉइंट जो आपने निकाला है उसमें y V by, उसमें ये फ्रीजिंग रेशियो B by A रेशियो ऑफ राइजर टू V by A रेशियो ऑफ कास्टिंग है, y इज द वॉल्यूमेट्रिक रेशियो दैट इज वॉल्यूम ऑफ राइजर टू वॉल्यूम ऑफ कास्टिंग. वो x, y पॉइंट अगर इस केन कर्व के नीचे आता है तो देन दैट मीन्स that riser will not be able to compensate for the first two stage of shrinkage and your casting will become defective. Remember here this y is nothing but your volumetric ratio, that is VR upon VC, and your x here is nothing but the freezing ratio that I have written above, and that is what we call as modulus of riser divided by modulus of casting. And listen here carefully, modulus of riser is what? V by A ratio of riser, volume to surface area of ratio of riser. Modulus of casting क्या है? Volume to surface area ratio of the casting. And the same term can be written like this na. Instead of writing V by A of riser divided by V by A ratio of casting, you can write it like A by V ratio of casting divided by A by V ratio of riser. Yes, my dear students. Now, come on. Let's move to the next point. Here, this curve is defined by this equation x is equal to A upon y minus b plus c, where this x is your undoubtedly freezing ratio, y is your volumetric ratio, and a, b and c, these are all termed as the Keynes constants, and for different materials their values will be different. Yes, a, b and c are what we call as Keynes constants. A, B and C are the Keynes constants. Now, let's move to the next method. Another method is called as naval research method. naval research method. It is quite similar to Keynes method, and it was at first developed in American Naval Laboratory, and that's why the name comes naval research method. As per this method, my dear students, at first you find this x here. This x is what? Showing you the shape factor. X is what? Showing you the shape factor. Shape factor. This is your shape factor on x-axis, and on y-axis we have, again similar to that Keynes method, the volumetric ratio. Similar to Keynes method, we have this volumetric ratio, that is VR upon VC. Nothing but VR upon VC. So at first, for a given riser and casting pair, we find x value. X is what? X is actually called as shape factor, and this is given by x is equal to length plus width upon thickness. Now, what is length and width and thickness? Casting length, casting width, and casting thickness. L, W, and T are the dimensions of casting. Are the dimensions of casting. Then, dear students, we find something called as volumetric ratio. What is this volumetric ratio? This is like Y, which is given by VR upon VC. Volume of riser divided by volume of casting. Now, dear students, for the different materials in the foundry lab, you will have this already plotted curves with you, the naval research curves. You find x value and y value for a given pair of riser and the casting. In case, my dear, if this x comma y value means x comma y point lies above this curve, this naval research curve, then it is called as sound casting. But in case if that x comma y point lies below this curve, then it is called as, or it will be a defective casting, as the given riser will not be able to compensate for the shrinkage. Now here a beautiful question can be asked, that find the shape factor for a hollow cylinder. Yes, if it's a hollow cylinder, you see, this is how it is going to appear. So it will have some dimensions like there will some internal diameter. Yes, this will be your internal diameter di. There will be this external diameter d naught. There will be this height, let us say h. Now for this we have to calculate the shape factor. So for that, first we need the length. Length will be how much? Length will be how much? Length is going to be equal to, you cut this cylinder and you simply make it like a slab. You cut this hollow cylinder and you simply fold it like a slab. So what will you get? An average length. Thank you, Rajpal Singh Chauhan. Thank you, thanks a lot. You are saying that very big fan of you are very big fan of me. Thanks a lot for saying these kind words. So L will be equal to pi d naught plus pi di upon 2. What I am saying you is to cut this cylinder from here and spread it. इसको फैला दो स्लैब की तरह. तो जो लेंथ बन के इसका निकलेगा, इसको काट के ऐसा फैला दोगे तो ऐसा होगा ना. You cut it and spread it like a slab. So this is going to be like this. So this length, outer surface, is going to be pi d naught. This length is going to be pi di. So what will be the average length? That's what we are calculating as L. That will be pi d naught plus pi di by 2. Now, how much is this width? This height is your width. This is going to be your width. Yes, W is equal to H. This much is what? Let us say if width, then this is going to be H. And what will be thickness? This is going to be your thickness. Yes, this is going to be your thickness. And this thickness will be how much, dear? This will be this. So this is thickness is equal to pi d naught minus pi di upon 2. So shape factor, if you calculate for this hollow cylinder, this is going to be L plus W upon T. So these values simply you put and you are going to get what? I'm sorry, I wrote it, those things there. Na? I'll erase and I'll write it here. I'm sorry. Because that will not be visible to you. It will be visible to you just a minute. If I move myself on top, yes, let me move myself on top, then it will be visible to you, right? Come on, man. Yes. Now I think it's visible to all of you. Very much clear? This much is going to be the shape factor. Simply you find L, you found W, that will be equal to H, and thickness you found this much. This is your thickness, right? So this is going to be how much? Pi d naught minus pi di by 2. Yes, very much clear. Great. So this is your Naval's research method. How many methods we studied? This was the first method of riser design. That is what we call as modulus. By the way, what is modulus? Modulus is defined as V by A ratio of any cavity, whether it's a casting cavity or a riser cavity. What is modulus? VR upon AR ratio. That is what we call as modulus, and that is equal to how much? 1.2 times VC upon AC. VC upon AC is what? Modulus of casting. Yes. Then I explained this Keynes method. As per Keynes method, first you have to find freezing ratio X, which is going to be MR by MC. That is V by A ratio of riser to B by A ratio of casting. That is A by V ratio of casting divided by A by V ratio of riser. Y is what? Volumetric ratio VR upon VC. X is going to be equal to A upon Y minus B plus C. This is the Keynes equation. A, B, C are Keynes constants. You find the X comma Y values for a given riser and casting combination. If that X comma Y value lies above this Keynes curve, then the casting will be sound. But if this X comma Y value lies like at these points, that is below this curve, then the casting will be defective. Then I explained to you this Naval's research method. As per this method, shape factor X is given by length plus width upon thickness, where L, W and T are the dimension of the casting. Volumetric ratio, first you find like VR by VC, like the way you did for the Keynes method. Shape factor on x-axis, volumetric ratio on y-axis, and this Naval's curve will be available to you for different materials in your foundry lab. Now you put X comma Y values for the given pair of riser and casting, the riser that you are going to design. If the X comma Y value lies above this curve, the casting will be called as sound. If X comma Y value lies below this curve, the casting will be called defective. Moreover, my dear students, this question is very important question. Since Naval research method is applied to slab, they can ask you a tricky question to find the shape factor for a hollow cylinder. Hollow cylinder having internal diameter di, external diameter d naught and height h. Now dear students, how will you find the length? You cut this hollow cylinder, you spread it. So external surface length will become pi d naught, internal surface length will be pi di. Yes, so the length will be the average length, this one, and that will be pi d naught plus pi di by 2. And then if you cut it and spread it, this is going to be your what? Width. So width became h. And what is going to be the thickness? This much is going to be the thickness. This is your thickness, right, from here to there. And if you find this is going to be equal to pi d naught minus pi di by 2. So shape factor you can now easily find by putting this length here, this width there, and the thickness here, right? That is how you will get the value of the shape factor for this hollow cylinder, and it's not that tough to find. Yes, very much clear to all of you? No problem at all? So these are the three methods, and these are the three different methods which are VVI for this GATE exam. Very, very important for GATE, upcoming GATE exam. This also very, very important for upcoming GATE exam, because for many years they have not asked this Keynes method. So this year this method becomes very much important for especially GATE 21. Modulus method is a very simple method, and recently a question was asked, so less chance is there. But yes, you should remember this small relation, that modulus of riser should be equal to 1.2 times the modulus of casting. So these are the different methods. Modulus method, one method, then Keynes method, another method, and then Naval's research method. Naval's, I forgot to write apostrophe s. Naval's research method, the another method for the design of riser. Apart from that, you have to keep in mind that risers are always designed for their minimum surface area, because the solidification time of the riser must be smaller than the solidification time of the casting. So with this, our riser design is complete. Tomorrow's session, that will be sharply at 7:30 p.m. I invite you all, because we are going to solve some very beautiful questions tomorrow, means 12th. We are going to solve some very beautiful questions. Yes, based on solidification time, and riser design. Tomorrow's session is very, very important session. I will ask all of you to join it live. We are going to solve some very much important questions on solidification time and riser design. By the way, myself Rajeev Singh, I am a plus educator on Unacademy platform. This is the referral code for your discount if you take subscription. Okay, RK007, keep this in mind and revise these three methods tonight itself. Tomorrow come for the questions. Till that, bye bye. See you all.